You must have heard this phrase somewhere before. If you're fast enough, time slows down for you. You age more slowly. Maybe in a movie, maybe someone has already explained this to you in a hurry and you just nodded your head without really understanding. But do you really know why? Not the Hollywood version, not the version that's like, it's this way because Einstein said so, period. The real version, the one that, after you understand it, makes you sit there staring at the ceiling for a long time. Because the answer isn't what you imagine. It's not space doing something strange to your body. It's not radiation. It's not the weightlessness. It's not some exotic effect reserved for the far reaches of the universe. It's something much more fundamental, much more disturbing. It has to do with what time really is. Let's start simple. Now you are sitting still, but actually you're not. At this very moment, even without moving an inch, you are shooting through space at about 30 kilometers per second because the Earth orbits around the Sun. The Sun, in turn, shoots around the center of the Milky Way at about 230 kilometers per second. And the entire galaxy moves through the universe at a few hundred more kilometers per second. You are never really still, not even for a second, in your entire life. But here's the first twist. None of that is what really matters here. Because in physics, motion is relative. There is no fixed background, no universal zero point from which to measure speed. You can only measure speed in relation to something else. So forget the galaxy, forget the solar system. Imagine something simpler. You and a friend alone in empty space, nothing else around. You are moving away from each other at half the speed of light. Which one of you is moving? You could say that both of you are moving, or that you are standing still and it's your friend who is moving, or the other way around. And here's the part that gets unsettling. All of you are right at the same time. Each of these answers is just as valid as the others. No experiment, no measurement will ever tell you which one of you is really moving. Motion is not absolute, it's relative, always. It seems like a philosophical detail, a subtlety without much practical importance. Actually, it's the most important idea in this whole story. Now let's talk about light. At the end of the 19th century, physicists tried to measure the speed of light in relation to the movement of the Earth. The idea seems simple. If you are on a moving train and throw a ball forward, the ball moves faster relative to the ground than if you had thrown it while standing still. You simply add the speed of the ball to that of the train. Light should work the same way, shouldn't it? If the Earth moves through space, the light measured in the direction of that movement should seem a little faster, and in the opposite direction, a little slower. They measured repeatedly, in all directions, at all times of the year, while the Earth revolved around the Sun. The speed of light was exactly the same. Every time, in every direction. The Earth's speed didn't matter. It didn't matter which direction the measurement was taken in. The result was always the same number, always. 299,792,458 meters per second. Exactly, that broke physics. Not in the figurative sense. It literally broke the understanding people had of reality. Because if the speed of light is the same for everyone, no matter how each one is moving, then the universe is doing something profoundly strange for that to hold true. It was a young employee at the patent office in Bern, Switzerland, who understood what was happening in 1905. His name was Albert Einstein. His reasoning: if the speed of light is always the same, and if motion is always relative, then something else has to give. Something has to change for that number to remain constant. That thing is time. Here's the main idea, and I'd like you to pause for a moment to let it sink in. because this is honestly one of the most beautiful and most disturbing things in all of physics. You are moving through space-time all the time at the speed of light, not just through space, through space-time. Einstein showed that space and time are not two separate things. They form a single four-dimensional fabric. And everything that exists in the universe moves constantly through this fabric, exactly at the speed of light. Always, without exception. But here's the twist. This movement is divided between space and time. If you are perfectly still in space, all your movement through space-time goes through time. You age at the maximum possible rate. Your clock runs as fast as it can. But as soon as you start moving through space, a part of that movement is diverted. You start using part of your space-time speed to move through space, which leaves less for moving through time. So time slows down for you. The faster you move through space, the slower you move through time. These two things are directly connected mathematically in a way that's impossible to get around. This isn't a side effect. It's not an approximation. It's the very structure of reality itself. Your total speed through space-time is always exactly the speed of light. You're always spending it somewhere. The only question is how you divide that between space and time. Let's make this concrete, because abstraction is good, but numbers anchor things in reality. Imagine a spaceship leaving Earth to reach a star 10 light-years away, traveling at 99% the speed of light. Seen from Earth, this journey takes just over 10 years. You see the spaceship leave, you wait 10 years, it arrives. But on board, the clocks tell a completely different story. Because of time dilation, the crew ages only about 1 year and 4 months during the entire trip. While 10 years pass on Earth, less than 1.5 years passes for them. They didn't cheat, they didn't sleep during the trip, they didn't experience anything out of the ordinary. Every second on board felt like a perfectly normal second. Their hearts beat normally, their coffee cooled down normally, their hair grew normally. Simply, fewer of those seconds passed because they were moving very fast through space, and because of that, very slowly through time. Let's push this even further. Imagine that same spaceship traveling at 99.9999% of the speed of light. The same 10 light-year journey takes only 5 days. For the crew, those 5 days pass normally. Meanwhile, more than 10 years pass on Earth. You leave Earth on a Monday. You arrive near the star 10 light-years away on the following Saturday. You turn around, come back at the same speed, and get off the ship 2 weeks older. Everyone you left behind has aged 20 years. This isn't science fiction. It's not speculation. It's measured, tested, confirmed physics. It was verified with atomic clocks on board airplanes. It was verified with particles and accelerators. GPS satellites need to correct for this effect every day. Otherwise, the navigation system would drift several kilometers in just a few hours. Time dilation is not theoretical at all. It's engineering. It's built into the technology you use right now. But here's the question you should be asking yourself right now. What exactly happens at the speed of light? If moving fast through space slows down your time, what happens when you reach the maximum speed? When all your movement through space-time goes through space and no longer through time, time stops. It doesn't slow down much, not almost to zero. It stops completely. A photon of light traveling exactly at the speed of light experiences absolutely no time between the moment it is emitted and the moment it is absorbed. From the photon's point of view, if it could have one, no time passes, never. A photon that left a star 1 billion light-years away and reaches your eye at this very moment experienced that journey as instantaneous. It didn't wait 1 billion years. It didn't age. It didn't experience anything. It was simply in one place, then in another, with no time in between. That's why traveling at the speed of light wouldn't make you age. Because at the speed of light, aging no longer exists. There is no more time. Time would have been entirely replaced by movement in space. Of course, you'll never actually be able to reach the speed of light because you have mass. And taking a mass to the speed of light would require infinite energy. This little timeless clockwork trick is reserved for massless particles like photons. For everything that has mass, time only slows down. It never stops completely. This is where it gets really weird. Everything we just saw, the time dilation, the way movement slows down your clock, has an equally bizarre counterpart. Space itself contracts. When you move really fast, the space in the direction of your movement shrinks. The faster you go, the more it shrinks. At the speed of light, the distance in the direction of travel would literally shrink to zero. This is called length contraction, and it's just as real as time dilation. So, from the point of view of the crew on board the ship, they're not just experiencing time more slowly. The distance between Earth and the star has physically shrunk for them. The journey isn't 10 light years long from their point of view, it's much shorter. That's why it takes less time. Not only because their clock runs slower, but because the distance to travel has actually decreased. The universe literally rearranges its geometry around an object that moves fast. From the outside, you see the ship speeding by and its clocks running slow. From inside, the crew sees themselves as stationary and sees the universe contracting in the direction of travel. Both points of view are equally valid, equally real. Neither of them is wrong. That's what Einstein meant by relativity. Not that everything is subjective, not that there is no truth at all, but that observers moving at different speeds actually experience different versions of reality. And all these versions are equally correct descriptions of the universe. Let's pause for a moment to consider what this means for your life right now. At this very moment, there are billions of other observers in the universe moving at different speeds relative to you. Each of them experiences time at a slightly different pace. Each of them has a now that's slightly different from yours. The idea of a universal now, a single instant that everyone would share at exactly the same time, doesn't exist. It's an illusion born from the fact that we all move more or less at the same speed, slowly on the surface of a single planet. Two observers moving at different speeds may disagree about whether two events happened at the same time. Not because either of them is wrong, not because their instruments are faulty, but because simultaneity itself is relative. There is no absolute before and after in the universe. There is only before and after, defined from a specific point of view. This is not philosophy. It's not interpretation. It's what the equations say and what the experiments confirm. Your intuition keeps insisting. There should be a single universal clock marking moments that everyone shares. There isn't one. There never was one. The universe doesn't have a clock. Each object moving in it carries its own. And all these clocks run at different rates depending on the speed at which they move. So why does none of this seem real to us? Because we move way too slowly. At our everyday speeds, time dilation exists, but it's so tiny that it remains completely undetectable to our senses. A commercial airplane flies at about 900 kilometers per hour. At that speed, time dilation amounts to a few nanoseconds per hour. Your body can't feel nanoseconds. Your brain can't perceive them. So you never notice anything. But the universe doesn't care if you notice anything. This is happening. Now, your feet, being slightly closer to the center of the earth than your head, age just a little bit slower than your head. It's real, measured, confirmed. On the human scale, these effects are invisible. At relativistic speeds, they become impossible to ignore. At the speed of light, they become everything. Since I really understood this whole space-time budget thing, I haven't looked at a clock the same way. I know that mine right now is running a little slower than that of someone standing on top of a mountain a bit farther from the center of the Earth. It's nothing, a fraction of a second in an entire lifetime. But that stopped being an abstraction for me. It's a fact as concrete as the ground beneath my feet. Here's something I'd like you to take with you. Time isn't a river that flows at a constant speed, the same for everyone. Time is a dimension, like space, and you move through it just like you move through space. And just like you can slow down your movement through space by redirecting your energy elsewhere, you can slow down your movement through time by redirecting it to movement in space. The universe gave you a fixed budget, a speed limit always exactly equal to 299,792,458 meters per second through space-time. You are always spending it. At every moment of your life, you use a little. The only question is whether you spend it standing still, and because of that, aging or moving fast, and because of that, aging slowly. A photon spends all its budget on movement, nothing on time. It doesn't age because it traded every last bit of its space-time budget for speed. You spend almost all your budget on time. You are, on the cosmic scale, practically standing still. You age at a rate close to the maximum possible, and somewhere between the two, there's a slider. Push it towards speed and you age more slowly. Push it to the limit and you completely stop aging. The universe doesn't hide any of this from you. It only shows you the price.